Welcome back. Let's do question 1-1. Truck drivers travel at a certain distance and have a rest before traveling further. A driver kept record of the distance he traveled in kilometers on 8 trips and the amount of time he rested in minutes before he continued his journey. The information is given in the table below. So we have the first row, which is the distance traveled in kilometers. That's our x. Then the amount of rest time in minutes. Just take note of that, right? And then that is y. Determine the equation of the least squares regression line for the data. So here we have to use a calculator. Okay, we have to know how to use our calculator. Let's use our calculator. And then what do we do? So you come to mode, right? Our calculators may be different. You check states. Okay, statistics. In this calculator is number 3. In another calculator it may be a different number. So you press 3. And then we want the equation of the least squares regression line. So we choose a plus bx. Okay, so you choose a plus bx. In this calculator is 2. And then you enter your values. You enter your data. So let's start with x. So it's 180, 200, 400, 600, 170, 350, 270, 300. So we enter all those under x. 180, then you press the equal sign. You see, the data has been entered. You go to the next one. 200 equals 400 equals. You continue like that. You enter all of them. Right, so we've entered all the x values. Now we have to enter the y. You go up, and then we're entering y now. See now, 20 equals 25 equals 55 equals. You enter all the y values. Then the last one, 45 equals. Then what do you do after that? Press AC and then shift 1. Okay, now we want the equation of the least squares regression line. So here, regression line, you see it's number 5 in this calculator. So we press 5. Well, you see that. Then we can find our A and B. Remember, the equation of the regression line is in the form y is equal to a plus bx. Now, how do we get our A? So A in this calculator is 1. So you press 1 and then equals. Right, so this is negative 23,84618721. Right, you can record that. Right, how to get B? Press shift again, shift 1. And then we still want regression line here, so you press 5. And then there's B there. B is number 2, so you press 2. Then equals 0.22703218853. So you can also write that. So now we can write our equation for the least squares regression line for the data, which is y a. Our a is negative 23,85. If round off to 2 decimal places, then plus 0, this is a comma, there's a comma there, 0,23. If round off to 2 decimal places, x like this. This is our regression line. So we have the value of a, we have the value of b, we have the equation. That is 3 marks. Right, question 1.2. If a truck driver traveled 550 kilometers, predict the amount of time in minutes that he should rest before continuing his journey. Right, in the previous lesson, we found the equation of the least squares regression line, which was y is equal to, because that is negative 23,85 plus 0,23x, isn't it? Now we want to predict using this equation. So the distance here is 550 kilometers. So where there's x, we put 550. So y is equal to negative 23,85 plus 0,23 times 550. Okay, you can just put this in the calculator. then y is equal to 102,65 minutes. These are minutes. Right. Okay. If you use the calculator to find the value of y, you're going to get maybe 101,02 minutes. This is what you get if you use a calculator. Right. 1.3, it says write down the correlation coefficient of the data. Right. So what do we do? We just have to use the calculator. Even the instruction says write down. So it means you don't have to do a lot of things. Let's use our calculator to do that. Press mode, and then you look for states, which is in this calculator is 3. It may be different in your calculator. So we press 3, and then we're looking for the correlation coefficient. Press where it says a plus bx, which is 2, a plus bx, which is 2, just like we did when we were finding the equation of the least squares regression line. Right, so press 2, and then enter the values 180, 200, 400 up to 300. So 180, enter the value, equals 200, equals like that. So let's enter all of them, the x values. Then 300, the last one, 300 equals. Now we have to enter the y values. 180 goes with 20, and then 200 goes with 25. We enter 55, 120. Once you've done that, you press AC and then shift 1. Okay, what are we looking for? We're looking for the correlation coefficient. So you press 5, right, for regression there, and then you're looking for R, which is 3 in this calculator, and then press 3, and then equals. So this is our correlation coefficient, 0.982970196, but in two decimal places this is 0.98. Right, let's do 1.4. 1.4 is supposed to interpret the answer we got in 1.3. Right, in 1.3 we found that our correlation coefficient is approximately 0.98. So what is the meaning of this? The correlation coefficient measures the strength of linear association. Right? It shows us how these two variables, x and y, are related. These are values without any units, which are between -1 and 1. If the value is closer to 1, it shows us that there's a strong positive correlation. If the value is closer to -1, it means it's a strong negative correlation. Let's say the value may be 0.7. It could be around moderate positive correlation. Let's say negative 0.6, moderate negative correlation, something like that. But let's say it may be 0.3, 0.2. This one is not showing us any correlation at all. So for a strong positive correlation, the value should be closer to 1. And for a strong negative correlation, the value should be closer to -1. So in this case, 0.98 is closer to 1. So this shows us a very strong positive correlation. 1.5. At each stop, the truck driver spent money buying food and other refreshments. The amount spent in runs is given in the table below. We have these amounts. How many of them? 1, 2, 3, 4, 5, 6, 7, 8. 151. Calculate the mean amount of money you spend at each shop. So what do we do? The mean amount, we add the data items and divide by the number of those data items. So there are 8 of them. So the mean here is equal to the sum of this 100 plus 150 plus 130 plus 200 plus 50 plus 180 plus 200 plus 190. You will get 1200, right? Then divided by 8. And then you get that the mean is 150 rands. Okay, that's the mean there, right? And then 152. Calculate the standard deviation for the data. So this one we have to use the calculator. Let's do that. All right, so what we do, we go to mode and then states, look for states there. In this calculator is 3. And then you go to 1 minus VAR. In this case, it's number 1 there. So you enter 1. And then enter your values 100, 150 up to 190. So it's 100, 150. You can actually find your mean using the calculator also. And the last value 190. Then equals. Press AC, then shift 1. Okay, what are we looking for? We're looking for standard deviation. So we come here to VAR, which is 4 in this calculator. Press 4. And then see, 2 is the mean. Into 3 there is standard deviation. So you press 3, then equals. Right, this is standard deviation 50,49752,469. Rounded off to 2 decimal places. Because of this 7, this will become 50. So it's 50,50. That's the standard deviation. 153. At how many stops did the driver spend an amount that was less than 1 standard deviation below the mean? Right, 1 standard deviation below the mean. The amount that was less than 1 standard deviation below the mean. So what is 1 standard deviation below the mean? So it means you have to say the mean minus standard deviation. 150, that's our mean, minus 50,50. And then we get what? We get 99,5. So this is 1 standard deviation below the mean. Right, we're looking for the amount that is less than this. Which amount is that? 100 is above, 150 is above that, 130 is above that. So we have 50, which is below that. So we have only 1 stop where he used an amount less than 1 standard deviation below the mean. If you say 1 standard deviation above the mean, then you say mean plus standard deviation.